Hey guys, I'm Hackerman. Today I'm gonna show you how to hack common household objects back or forward in time.
Time travel is a concept in science fiction that's been talked about a lot. It's been speculated in many ways, exploring not only its possibilities, but also its various consequences and possible rules. As with most science fiction, some of it is speculative and some of it has hard science to back it up. A lot of the best science fiction out there is that which is accurately grounded in hard science, but has a dash of speculative science that makes it interesting. And someday that speculation might turn into hard science as well. And this has happened before in older sci-fi stories. And what I love doing with science fiction is looking at how accurate they are in reality, looking into the hard science behind the story. So now I present to you Anime Science, a new series where I talk about science fiction elements from various animes and show how accurate the hard science behind it is, how possible they actually are in reality, and how weird we could get with them. And I figured I'd start this series with a science fiction show that most people who watch anime know about, Steins Gate. There are a couple science fiction topics we could approach in this show and its sequel, but for now we'll stick with the show's core premise of time travel theory. The show and the visual novel do really well with acknowledging and talking briefly about the many actual time travel theories that are widely accepted in science. Each can be really confusing to understand in themselves, but I'm going to talk about the theory that's mainly used in the show, which is black hole theory. If you're a fan of the show, you'll recall that the show uses concepts of worldlines and Kerr black holes to explain time travel. But what really is a world line or a black hole? What's the difference between a black hole and a Kerr black hole? How do they work and how can they let you travel through time? In fact, what really is time and how can we manipulate it if at all? These are the main questions I'm going to try to answer, break down, and explore in this video. My goal is to explain the basic ideas of these concepts and what we currently know and don't know in science about them. I'm going to do my best to compile all the information I've gathered and answer these questions as best as I can. Keep in mind, I'm not a science expert. I just find these concepts to be very interesting to look into. So that being said, a lot of this is all theoretical and hypothetical, but there are other factors that might not be accounted for. I also want to especially point out that some of the information of what happens inside a black hole is mostly just theories right now and might not turn out to be true when we find out more about them. This is because it's really hard for us to know what's actually going on inside a black hole itself. Again, a lot of this information is only theoretically possible, but practically it could never work the way we want. Some parts might be mathematically possible, but physics, quantum mechanics, or other fields of science might reject it. For example, some parts might only work if something has no mass, or maybe has to move faster than the speed of light. But we're going to go down the theoretical rabbit holes and see what could happen. With all that out of the way, let's get started. First things first, let's talk about world lines and space-time. Space-time is the idea of combining the three dimensions of space with the one dimension of time to make it 4 dimensions. It's usually shown as a 3-dimensional grid, but it's bending and warping around mass. We'll go over why mass causes it to bend and warp later, but keep it in mind because it's important to understand time in general. World lines are a path that an object traces in 4-dimensional space-time. If you watch Steins Gate, you probably get the general premise already. It's basically a record of where and when an object has been during its existence in the universe. This is important to conceptualize because when you think about it, going backwards in a world line doesn't mean you can change the past. We'll talk about why you can't later, but if you finish Steins Gate, then you probably understand it already. Now let's talk about the time travel methods used in Steins Gate themselves. There are 3 different forms of time travel devices used throughout the show: D-mails, the time leap machine, and the actual time machine. D-mails are text messages sent from the future into the past via a microwave oven and a large CRT television. This causes world lines to change for Okabe, but he has an ability known as reading Steiner that makes him conscious of these world line changes. Technically speaking, if you changed world lines, you probably wouldn't even know because your consciousness would just be the consciousness that existed on that world line, memories and all. But that aside, with D-mails, Okabe hasn't really altered the past per se. He's more just made himself jump to a different world line where the past was different. Since his consciousness travels with him, he perceives the past to have changed. The second form of time travel used is the time leap machine, which was a device they made to compress a person's consciousness into data and then send it back in time, in a similar way to D-mails. This makes it so that you haven't changed the world line, but your consciousness went back in time. So, effectively, you've gone back in time, which, as I mentioned before, means that you can't really change it much. Staying in the same world line doesn't mean mean you can change the past. And this ends up being a very traumatic problem for Okabe, as he realizes no matter how many times he tries, he can't stop his friend from dying using this device. And the last form of time travel used was the actual time machine that you see at the end. With this, you could physically travel forward and backwards on the current world line, both body and consciousness. But since you're still on the current world line, you still can't change the past. In fact, with the actual time machine, your future self will have always been a part of that point in the world line that you travel to. So you effectively just complete a time loop. And you can see this happen in the beginning and end of Steins Gate. Don't worry if that's confusing you right now, we'll go over more of what that means later in the video. Now that we've recapped world lines and the 3 time travel mechanics used in the show, let's start breaking down the main time travel theory the show uses to power these devices. First, we have to understand more about what time itself is and how it can be affected. You might think that time is a constant, something that occurs continuously over time or something that doesn't change. It ticks forward at the same pace for everyone everywhere. But a smart science guy we all know, Einstein, believed that time is relative, meaning that it can be experienced differently between 2 observers based on different factors. In 1905, his theory of special relativity said that the speed of time can change depending on your speed relative to something else. For example, if you have a twin and they stay on Earth, while you fly a spaceship, you'll age slower than your twin back on Earth. 10 years later, Einstein showed with his theory of general relativity that gravity can bend time. How does that happen? Well, the mass of an object makes space-time bend. Alright, but what does that mean? Well, let's break it down. As I said in the beginning, space-time is when you combine 3 dimensions of space with 1 dimension of time. And it's shown as kind of a 3-dimensional grid, but it's bending and warping around mass. The curvature that's caused by this warping is what we call gravity. Objects move along this curvature without knowing it, and the more warped it is, the longer it could take to travel on it. Imagine this grid, but without a mass warping the grid. An object can move along this grid pretty fast, but an object moving on a grid that does have mass warping it would take it longer to move along the path because of the curvature that's now there. So since space-time bends like this, we can see that gravity affects time since objects will move along this curved path which gravity can affect. The bottom line? Velocity and gravity affect how one experiences time compared to others. And these theories have been proven by satellites that were sent out into space with clocks on them. When they came back to Earth, they found that the clocks had actually gained microseconds, meaning that for those clocks, time was slower in space than on Earth. This is known as time dilation, or the difference in elapsed time between 2 observers, either through a difference in velocity or gravitational fields. Through gravitational time dilation, it's possible to travel to the future if you can withstand a massive amount of gravitational force for a period of time. But it could only be used to go to the future. And in the movie Interstellar, this is actually what's used when they go to a planet where every hour there is equal to 7 years back on Earth. Alright, so now that we understand more about time and what can be done with it, let's talk about black holes. They sound scary and mysterious, but what exactly are they? Well, a black hole is typically a star that's collapsed under its own gravity and has such a strong gravitational force that nothing, not even light, can escape from it. Since light can't escape from the inside of it, meaning light can't reflect, the region appears as a massive black area, hence the name black hole. An important part of a black hole is the event horizon, which is the point where escape from a black hole becomes impossible. It's called this because any events that happen past this point can't be observed by something outside of this point. The theorized reason for the event horizon being the point of no return is kind of weird, and also might be what makes it possible for it to be used in time travel. It's believed that inside the event horizon, the coordinates of space and time are swapped. What does this mean? Normally, we can move forward, backwards, up, down, left, or right in space, but time is always moving forward, not backwards or side to side. That's what happens normally. But if we were to swap space and time, you would now see that you could only go forward in space, but now time can go in various directions, including backwards. This means theoretically you could travel back in time into parallel worlds, or more likely both while traveling in the event horizon. However, there's a problem with this because of another part of the black hole called the singularity. The singularity is the center of a black hole, where the space-time curvature becomes infinite. It has no volume and infinite density, something that falls into into a non-rotating and non-charged black hole cannot avoid entering the singularity. And when they reach the singularity, they're crushed to infinite density, and then their mass is added to the black holes. That sounds terrifying to me. So if we enter a black hole, somehow didn't die from the experience, and were to ignore many other factors that make travel in a black hole practically impossible, we would travel through time and into possibly other universes, but still eventually end up consumed by the singularity, so none of it ends up mattering. However, with a rotating non-charged black hole, known as a Kerr black hole, it's possible to avoid the singularity. In fact, it's also hypothetically possible to exit Kerr black holes, which means we would enter into a different part of space-time because of our time in the event horizon. The black hole basically acts like a wormhole, which is kind of a bridge linking two different points of space-time, which means, in theory, entering and exiting a Kerr black hole could allow you to travel through time, although you wouldn't know where or when you'd go, and you'd probably end up in a different universe. You might be asking what's so different about a rotating black hole that makes this possible. So let's talk about a Kerr black hole. While a singularity in a non-rotating black hole is a small spherical point in the center, but in a rotating black hole, the singularity is shaped like a ring. This ring can hypothetically be avoided by maneuvering a certain way, but like we said before, once you enter an event horizon, you can only go forward, right? So how can you avoid the singularity? Well, a rotating black hole also has two event horizons. They're called the inner and outer event horizons. So inside of a black hole, the swapping of space and time occurs twice, which is what would allow you to maneuver your way into avoiding the singularity, since when you enter the inner horizon, you can now move in space again. Here's what happens. You go to a Kerr black hole. You enter the outer horizons, which is basically the same thing as the event horizon we talked about before. You enter the outer horizon and you can travel backwards or side to side in time, but you must move forward in space. Then you enter the inner horizon, where you can only go forward in time, but now you can move around again in space. So the outer horizon is basically the event horizon we already know, but the inner horizon swaps time and space back to normal. Once you regain control over space, you now would try to avoid the singularity. The inner horizon also has what are called closed timelike curves, or CTCs. A closed timelike curve is basically a point in a world line where an object returns to a point it was at previously, meaning that objects travel backwards in time along its world line. CTCs are basically the idea behind how the actual time machine in Steins Gate works. It would utilize these CTCs to go back in the current world line. Now, you can go backwards in time on the current world line, but the world line of an object following a CTC doesn't change just because it follows the curve, meaning you can't really change the past. It's a closed loop, in that the object will return to a previous time, but nothing will change about its world line. It loops back and becomes the original timeline. So the object travels to the past, but it won't be able to change anything about the world line. If you were to travel back to the past using this loop, your future self will have basically always been a part of the past. Confusing? Let's look at an example then. Let's say you want to go to the past and give yourself advice for the future. You somehow use CTCs to travel back in time, but no matter how hard you try, you will never be able to talk to your past self directly. This is because you never did before you went back in time, meaning you will never be able to if you go back in time using CTCs. Now, instead of all that, let's say one day your future self visits you. Because your future self is now there, that means at one point in the future, you will also travel back in time to visit your past self, thereby becoming the future self that you met. This is something that cannot be changed. You will have to eventually do it because that's how these time-like loops work. Basically, if you haven't met yourself from the future yet, then you physically cannot go to the past to talk to yourself. And if you have met yourself from the future, then that means you will always go back in time at some point to talk to yourself. With CTCs and this world line, what has happened was always going to happen and always will happen. If you finish Steins Gate, you know that this concept is what helps Okabe to reach the true ending of the story. Because of all this, the idea of time travel causing paradoxes just aren't possible. So if you travel back in time using CTCs, don't worry about breaking the universe by accidentally creating a time paradox. You physically can't. But now, what if instead we change world lines? We would go backwards in time, on a different world line instead of the one we know about. This is likely what would happen anyways in a Kerr black hole, since we travel across different coordinates in time from the swapping of space and time that happens. And in Steins Gate, this is kind of what happens as a result of using D-mails or the time leap machine. With D-mails, Okabe is able to change world lines, but he doesn't go back in time himself. With the time leap machine, Okabe can go back in time, but he hasn't changed world lines, or at least he has, but only such a tiny bit that many key events are impossible to change, which explains why he can try to change the future in different ways but none of it works. If we were to combine the concepts of the D-mail and the time leap machine, that would more likely be what would happen if we were to successfully enter and exit a Kerr black hole. Now you're probably thinking, but how would we exit a Kerr black hole exactly? Assuming we can survive entering a black hole and travel through its two event horizons without being crushed and avoid its ring singularity, we now have to find a way out. And this is a part of my research where I had trouble finding a straight answer. A lot of my sources basically said if you can avoid the singularity, it's theoretically possible to escape a Kerr black hole, but a lot of them never really said how exactly you could. There are Penrose diagrams showing that it's possible though, so with those in my understanding of how the event horizons swap space and time, I think I can understand how it might work. So here's one way it might work. Basically, when you enter the outer horizon, you will continue going forward in space because of the swapping of space and time coordinates. Once you enter the inner horizon, they're swapped back to normal so you can control your position in space again. If you avoid the ring singularity, you could then leave the inner horizon and go into the outer horizon again. Once you re-enter it, space and time will be swapped again, only this time, since you entered the outer horizon from the inner horizon, forward in space would lead you out of the black hole. Since you're entering the outer horizon from the inside of the black hole instead of the outside, that means you'll be forced to move forward out of the black hole because of the swapping of space and time that occurs. Again though, it could be possible theoretically, but practically it might not work due to having to overcome numerous other factors that aren't accounted for. Most of the time, things get destroyed before they even enter the inner horizon, but then things that survive usually still end up falling into the singularity. Another possible theory for exiting a Kerr black hole that I found had to do with finding an entrance to a white hole. Now, a white hole is a theorized exact opposite of a black hole, meaning nothing can get in and everything has to go out. Once we enter a white hole, we would be pushed out of it into a different point in space-time. And the idea is a black hole might be connected to a white hole in another universe. White holes right now seem to be a hypothetical concept that hasn't been proven yet to exist, but it's been thought that they just might not be continuously observable like black holes. And interestingly enough, it's theorized that the Big Bang, the most widely accepted theory of the formation of our observable universe, was actually just a white hole. If that's true, that means entering one in the way that we've been thinking about might make you enter a new universe during its creation and then jump you to your new point in space-time along the world line, which basically means you'd enter into the universe during its creation and then immediately jump forward in time into your new point in space-time. And another idea that I'm assuming would get you out of the black hole would be using the CTCs inside the inner horizon. If you use a CTC to travel back on a world line, you could go back in time to a point where you aren't inside the black hole, but because of your change in space-time from traveling through the outer horizon, you wouldn't be on your original world line anymore. You would be in a different or parallel world line. Anyways, however you do it, the general idea is if you get out of a Kerr black hole, you end up in a different universe and a different point in space-time and are now on a different world line. Now that's all fine, but then how do they actually use time travel in Steins Gate? They never really enter and exit a Kerr black hole, right? Well, they never travel to a black hole that's created by a collapsed star. That's true. However, what they actually do is they create mini black holes, which is pretty much the main idea behind how time travel devices in general would work. If you have a device that can create a mini black hole and you can send information into and out of it without the information being destroyed or distorted in the process, you would have the general idea of a time travel device. Although technically all you'd really need is a device device that would be able to swap the coordinates of space and time, or a way to find and use CTCs. But right now a black hole is the best idea we have to do that. So how do we create a black hole? Is it actually possible for a microwave oven to create a black hole like in Steins Gate? And how does the time leap machine work with all this? Can we actually compress our consciousness into data as a means for actually going back into the past? Originally I was going to talk about all this in one video, but then I looked and I was already at 11 pages on the script and I wasn't even nearly done writing yet. There was a lot of concepts to explain with black holes, and there's a lot more we have to cover to see how accurate Steins Gate is. So we'll talk about all these new questions and more in the next episode of Anime Science. If you liked this and you want more of it, give this video a like, subscribe to the channel, and hey, maybe check out my Twitter and Twitch. Also, consider supporting me on Patreon, where you can see the effects of a black hole live. See, I take the money I get on there, and I convert it to mozzarella sticks, which I then absorb and add to my own mass, and I crush them into infinite density. And theoretically speaking, though not practically speaking, donating there could also help you travel through space-time, though you might not be able to observe it yourself. Just trust me on this one, just trust me. Anyways, thank you all so much for watching, and feel free to let me know what you thought about this in the comments below, or any questions or concerns you might have. And I'll see you guys in the next video. Goodbye.
Since I was a young man, I've had this plan to stay in Japan as some type of ninja picture, living like a Christian scripture, differ, thinking bigger, baptized in savannah.